Hello everyone, hope you're bright and shiny and I'm also in the pink. This is Jubair Ahmed and this is day 3 of our STL series. Today we'll be talking about stack. So what is a stack? So stack is like a container. It stores values. We can store multiple values, different types of values like string value, boolean value, not boolean actually, I mean string value, double value, integer value, those kind of. And the format that used to store values in stack is called LIFO. So what is LIFO? So LIFO means last in first out. So it means last in first out. So LIFO means last in first out. It means the value that's going to be the values that's going to be inputted in the stack will be the first value that I insert on a stack will be removed at the end. So that give you an example, let's say red, green, blue, yellow. So let's say this is the order that I have. In this order I have insert the values on a stack. So red is the first, green is second, blue is third, and yellow is fourth. So when I want to access a value and access and remove or want to get a value, the value I will be able to get will be yellow first, then blue, then green, then red. So last in first out. So the value that got in last in the value that got in the stack in the last position will get out first. So yellow is the last element here, but when when popping elements, the yellow will be the first to get popped. So this is the basic of stack, and I can't, like vector or array, I can't randomly access a stack element. So adding and removing and accessing all of those kind of operation will be possible from the back of the stack. So let's get into the implementation. So before to use it, so we have to first include the stack. Okay, and to create a stack, we have to use the stack keyword and then less than greater than, and inside that we'll name the what type of stack do I want. Let's say string type, and the name of our stack will be, let's say, giving a random name my stack. So in vector, we could we could insert value. We can initialize the stack just when we declares. So, but in stack we can't do that. We can't do like this. We can't do this. Let's say is another value. Okay, we can do this. So what we have to do is we have to use the push function. So my stack push, we're going to push some values, let's say red, push again, green, green, yellow. Let's say okay. So So I have listed all the operations that we'll be doing today. So those are these operations. These 9 operations will be doing on the stack. So we have created a stack. Now we will see how to access it and how to change the values, how to add and remove elements from a stack, how to know the size, and how to empty a stack, and how to look through and sort a stack. Okay, we have access a stack. No, we didn't have. My bad. Let's do that. So to access a stack, we have to, you know, write the name of the stack and then use the top function. So let's see out. So as you can see, the last element that got in the stack is purple. And when I top a function, when I top an element, the last element got out first, which is purple. So this is how we can access a stack. Then what we'll do, we have accessed it. I'm going to change an element. So to change anything in any container, we have to first access it, right? So we have accessed it, and now we're going to reassign a value. Let's say sky. Okay, now if I access that last value, what do you think? What will be printed? Purple or sky? It should be sky, and it's going to be sky. As you can see, it's sky because the last element is replaced. The purple is replaced with the sky, and when I print the last element with the top function, it's printing the sky. So we have accessed and changed an element from a stack. Now we will add and remove. So how do we add? So we have already added using the push command, using the push function. So we will now learn how to remove it. So let's say I want to remove the top top. I'm sorry, I want to remove the sky or the last two element. Last two element is sky and yellow because purple is already removed. It's replaced here. So let's say I want to remove. So let me write it here for you to better understand. So red is the first element. Then we have green. Then we have blue. Then we have yellow. But now we then we have purple, but since we replaced purple with sky, so there's sky. Okay, this is the stack order. Now let's say I was doing how to remove a element. We have to use the pop function. We have to first name our stack, my stack, and then pop. So then what this will do is this will remove sky from the stack. So the last, so when sky is removed, the last element is yellow. So if I pop now, if I access the last element of the stack, it will show yellow. Okay, it shows yellow, but it also shows sky. That's because it's reassigning here. Okay, to remove confusion, remove, let's delete that. So it should now print yellow only. As you can see, it's yellow. Okay, so we have learned how to remove, and let's know what's the size of a stack. Yeah, we have to print that size of stack. So my stack, the name of the stack, and then the function size. So it should 1, 2, 3, 4. It should print 4, yes. it has printed 4, which is the size. It's good. Which is the size. Okay. Now we will see if the stack is empty or not. See out my stack. We will use the empty function. Okay, let's see what we got. It should, yes, it should return 0 because 0, the empty function returns an boolean value, which is 0 and 1. 0 means no or negative. So if is the stack empty, it says negative because the stack is not empty. Okay, let's loop through a stack. Okay, so to loop through a stack doesn't support iterators, so we can't use a for loop directly. To use a for loop, we have to, get all those elements from the stack and put in and insert those in another container like vector and such. But to directly do loop through a stack, we can use the while loop, and we're going to use the condition that okay, we're going to use the until my stack is empty. What I'm going to do, I'm going to see out my stack dot top. So what I have done here, so I have write a condition that until the stack is empty, I will access all those elements. So it will be access yellow, it will access blue, it will access green, then it will access red. Okay, but I have to write, so it will access, but there's a problem here. The problem is I have to, after accessing it, yellow, I have to remove yellow. Then I will be able to access blue because stack, stack works in a LIFO format, in a LIFO architecture. Right, so the last element will be first out, and it's not, if it's not out, then how am I going to access the next one, right? So I have to pop it. I have to pop that element. Okay, now let's print. Yes, as you can see, yellow printed first, then blue, then green, then red. Okay, this is how we can loop through a stack. Another way I have already told you, I can use for loop, but I have to use another container. Let me show you how to do that. So the first I have to take, let's say container, let's say vector of string my vector. Okay, I have taken an empty vector, and I should add, even though bits and standard C++ header file has all those libraries, but just for learning purpose, I'm showing you that you have to use vector if you want to, if you don't use bits or slash standard C++ dot head dot h. So I have taken a vector. Now what I will do, I will take that vector and push all those stack elements. How do I do that? Okay, I'm going to take my stack and I'm going to top. Okay, in vector we can't use push, just push, we have to use push back. Okay, that I have done it. And then what I have to do, as usual rule, I have to empty the stack, which is use the pop function. And I want to then show, I want to print that vector. And how do I do that? Let's say I'm using a normal for loop. it will be starting from 0, then the size of my stack. I mean the size of my stack, or you know, I can use the size function, the vector size, or my second just I have used my stack size, because both will be equal, same. Now I want to print my vec. Okay, let's remove all these to avoid confusion. Let's remove unnecessary spaces for better readability. Okay, let's run it. Okay, there might be something. Okay, let's use the my vector size. How about that? Okay, now it worked. Okay, as you can see, yellow and I have this is my stack. Okay, red, green, blue, yellow, and purple. So what I have done is I have I have I have taken a vector container, and then what I have done, I have used a while loop to push back all the elements from the stack to the vector and pop each element inserting after pushbacking each one of the elements, and then I have looked through the vector and print all the elements. So why I have done this? Because this is very useful to sorting if I want to sort a vector. Let's say I want to use a sort function. I can't use the sort function on a stack, so I have to convert it into a vector. So now if I use the my vector again and from my vector and sorry there's a typo, if let's now print it. Okay, I'm going to use another formula. Let's okay, for learning purpose, let's show you the for each loop. Okay, my let's say I'm taking a value variable named val and take the my effect and then scale each of the value. Okay, there's a problem. It's what could be the problem. I can use auto. If I do auto, then it's not going to get an error. I hope. As you can see, there's no error. But what I want to do is but what I want to do is okay, let's see this first. Okay, so I have sorted it lexicographically in a dictionary order. So B is the smaller, C is greater than that, P is greater than that, R is greater than that, and Y is greater than that. So this is how I can sort a stack. So in this while loop, what I have done, I have pushed. So let's recap how I have sorted a stack. So stored a stack, I have used a temporary vector And then what I have done, I have used a while loop and then put all the elements in the vector. And then what I have done is, what I have done is I have I have iterated all the elements in the vector, and what I have done next is I have sorted the vector. I have sorted the vector, and then after sorting it, I have printed all the elements. So before sorting, it was like this, and after sorting, it was like this. So that's it for today. I hope you like it, and feel free to comment your thoughts. Any questions is welcome. Any criticism. I will see you in the next video. Thank you. Goodbye.